Welcome to the session. The name of the session is JavaScript for OCF Applications. And my name is Sakari Poussa. I'm from Intel. I'm based in Finland. And I have a small team which has been doing pretty much everything that I present here. So credit to the team. And if you have any questions, I try to run through my slides in a pace which gives us a little bit Q&A time. If not, you can reach me on Twitter. My Twitter handle is there. The presentation is online, and so you can check it out later. So what we're going to talk about today is many things. First of all, we talk about JavaScript. So before we dive in there, how many of you have used JavaScript in any of your past projects? Okay, so about 3/4. So that's good. So we first talk about the Node.JS and the Iotivity project, how we bind those two together. Then we talk about the cloud integration. Not entirely the way it was presented on the morning session, but this is a kind of a different approach with the similar goals. Then we talk about the Cordova, which is a API bridge for web mobile applications. And then at the end, we'll talk about several new projects where we have integrated or plans to integrate this solution, mainly Ostro, Zephyr, and then a little bit about the Soletta project. So with that, I'll start with the kind of a vision why we are doing this. And on the left-hand side, you have a kind of a fairly simplified IoT end-to-end picture where you have the clouds, you have mobile clients, and you have these gateways, and then all the way down to the smart sensors. And you have various protocols on the between the gateways and smart devices. On the clouds, mobile integration area, I would state that the options are less. So it's mainly based on REST APIs, one way or the other, over JSON or over SOAP. Nevertheless, then on the right-hand side, if you're thinking about the web platform, these are your building blocks, how you build your end-to-end applications. You need some storage, some resources, networking capabilities. In terms of the web platform, you need to have a JavaScript engine, web servers, API servers, and then finally a web application, whether it's an HTML5 application or Node.js application. And really the vision here is that you should be able to use JavaScript for everything. All the way down from the smart sensors running MCU, very limited resources. You do your programming with the JavaScript there. On a gateway, you can use JavaScript naturally on the cloud and then on the mobile clients. So this is what the team at Intel has been, my team has been driving for the past year. And certainly this is not the kind of the only solution. I mean, obviously you can use any language that is supported. But with this, you would get code reuse, consistent APIs, and consistent application development environment. Many of you may ask that JavaScript, why we're talking about JavaScript? And as Mike pointed out in his earlier keynote, there just isn't enough embedded developers, these core C masters who can do the embedded and let the IoT scale. So we need to have something for the web developers, which been doing these websites and World Wide Web type of applications for years, and in their toolbox, JavaScript is the programming language, and there's a huge amount of those. Same for the mobile app. Many of the mobile apps that you have on the mobile phones and tablets are actually written with the web app, with the web technologies, HTML5, CSS, and JavaScript. It's just packaged with the corresponding device and the App Store. So in that sense, if we can provide a good APIs and consistent environment in terms of JavaScript for IoT, we would address a whole different amount of developers in the ecosystem. And then for those who don't know about the Node.js, which is kind of the core ingredient in this presentation, it's a JavaScript runtime for headless devices. Headless meaning that you don't have the display. So you don't have extra code or cycles to render something on your screen, which is the case in the browser. The main ingredient in the Node.js is the V8 engine from Google. It's the engine for the Chrome browser as well. Late last year, Microsoft came out and open sourced or announced the plans of open sourcing their Chakra JavaScript engine, and it's been now integrated to the Node.js, so you can actually choose which engine you would use. And Microsoft is using this setup in their Azure Cloud IoT solution. The other big part of the Node is a synchronous event loop called libuv. And part of the success of the Node ecosystems being the Node Package Manager, NPM. So that's the biggest and fastest growing open source package repository. So you have a huge amount of packages, I think over 200,000 packages there in the npmjs.org. The Node itself has been open source since 2008 from a company called Joyent. And it's a pretty healthy open source project, many contributions from multiple companies. And the Node Foundation, which was formed late last year, kind of established the stable development environment and the project moving forward. And so then a few words about the Node.js and the IoT. Why do we want to do that? It's a fairly young project, but it was created by experienced developers, so they kind of knew what they wanted, and so it has a good architecture, and then it's throughout the design, it's synchronous with this libuv and synchronous event loop, so there's nothing that blocks it. And even though you have the JavaScript kind of an API layer there, that is just getting the API calls, and then it's handing over those to the libuv, which is a C++ library, which then spawns different threads. So nothing is blocking there. It's been fairly successful in terms of the adaptation. It started with the server-side applications. So there's a lot of companies with the success stories like Netflix and PayPal and Bank of America, which been successfully switched their legacy Java and other kind of a server-side applications using Node.js, and they're extremely happy with that. And it's been scaling now to the IoT world, and a clear indication of that one is the number of IoT-specific packages in the NPM. So you have CoAP and MQTT and those type of packages. And the latest Node.js conference, which been running multiple years. There's always been two tracks, front end and back end. This year there was a dedicated IoT track. So clearly the industry is moving that direction as well. It's a perfect choice for implementing RESTful services. We have REST APIs, and then extending that. I'll talk about that one in a second. You can use the modern tooling like Swagger or RAML to document and prototype your APIs. And last but not least is the full stack applications, meaning that you can actually write with the JavaScript both the server and the client side. And so you only need one set of skill sets in the team, and you can do some sharing in terms of the code base. So this is kind of a high-level reference architecture for an headless IoT gateway, if you will. And what you have there in the middle in the box is obviously you need the OS and the middleware and the normal libraries there. And then you run the Node.js there. The color codings are on the bottom left. So the blue one is a C or C++ code, and the yellow is JavaScript, and the orange stands for an API. So the Node.js itself, it's a mix of C++ and JavaScript. So the API layer on top is JavaScript, and then the actual core is C++. Then on the left-hand side, you have the Node modules. These are the NPM packages which kind of extend the Node. You can do those either in pure C or C++ or with the mix of JavaScript and C++. The Node itself has a core API which contains like 20 API categories like HTTP and security and networking and things like that. And then once you bring in your own modules or these NPM modules, they all have some sort of an API, how the web application, which is then next on the yellow there, can use. So the Node application that you write, that's pure JavaScript. There's no way other than the JavaScript. And then on top of that, the web application may or may not provide an API out of the box towards the world. If it doesn't need that, that's not a mandatory thing, but typically these headless devices, they need some way out to provide the services. Then talking about the developer offering, the core of this presentation is about API. And what I mean by that is that we have done a fairly extensive design of the API. And what I mean by that is that the kind of the easy route would have been that, okay, Iotivity has its C++ API, let's just wrap that and call it a day. But we have been, part of the team, and Intel has been fairly active in the W3C API design, which is defining the APIs for the browsers for the World Wide Web. And during that process, we kind of learned that, okay, the JavaScript APIs, they have different expectations from the developer, and they look and feel like JavaScript APIs instead of some kind of an alien wrapper APIs. So that's why we designed a OCF JavaScript API. We've done multiple iterations. We've been using that API, and in a real use cases, I'll talk about the our demo, which is actually visible there on the exhibit hall. So that's been kind of our main use case, and now the API is stable. We think that it's good. It hasn't been changing, and with that OCF JavaScript API, we have now implemented that in multiple places. Well, not just us, but other folks as well. So that you'll get the same API on the Node.js. You get the same API on Cordova, and Alternativity on the crosswalk web runtime. You have that also on the Tizen. Cisco did the implementation on Tizen, and we have the same API coming on the Soletta as well. The API highlights is presented here. I don't know if you can see the all the details, but there isn't much. I mean, in the OCF, you have the concept of a client and a server. The server being the resource, and then the client being the one that discovers the resources. So in terms of the clients, when you want to discover something, the only API, well, this is a highlight. There's a couple more, but you know, this is essentially what you need. You call a find resources, and then you register a event listener, which is a fairly standard way of programming JavaScript, and you wait for a resource found event. And once this server starts to report back that I'm here, you'll get a this resource found event, and with that you get a data which contains the resource, which is there on the bottom. And then once you have the resource, you can do the OCF operations there. You can either retrieve it, and you can update it, and you can start observing it. You can also do delete and things like that. And then that's about it. Then on the server side, you only have one call, which is register. It takes a bit of parameters that you know, what is the resource? You know, am I discoverable? Am I observable? You know, what is the JSON definition of the resource model that the OCF has, and then you call the register, and there's a couple of callbacks there that you pass to the register as well, and then you start waiting for the events. And so if somebody calls you on the find resources, you'll get a retrieve request, and then you fill out the data and call one of the callbacks. I'll show you a little bit the examples later on. But essentially, this is the API in a nutshell. And for those who know the Iotivity C or C++ API, can clearly see that this is a bit simpler, but that's the JavaScript way. Then a few words about the OCF and Iotivity. There's a good amount of data already on those ones, so I don't spend too much time on those. But on the Iotivity, the missing points in terms of the APIs, it has C, C++, Java, but there was no JavaScript. So that's why we step in and said that, hey, you know, I think it would be great to offer the JavaScript APIs for the Iotivity. So that's what we did, and so nodes plus Iotivity equals Iotivity nodes. By the way, the node Iotivity package name was already taken, so we need to kind of reverse that. But anyway, so that one brings a JavaScript API to the Iotivity, and it has this API, the OCF JavaScript API. It's open source, and it's based on the Iotivity 101, and we have the regular, you know, well, not right now. It's in a GitHub, Travis integration, a lot of sample codes, demos. We are moving the repository to the iotivity.org as we speak. And it's been used in the Iotivity, in the web services interface, in a REST API server, and in our smart home demo. And I'll talk about some other use cases later on. And so this is how it's done. So this is just kind of another snapshot of the reference architecture picture. So you have the Node.js there on the bottom. We have the Iotivity code base. We only use the C API, so we only compile and use I think the resource directory. We don't use any of the C++ bindings on top. Then we have the Iotivity node, which contains a bit of a C++ code, C and C++ code, and JavaScript. And then we have the common OCF JavaScript API, and then whatever the web application is, you can use all the capabilities of the OCF stack. Well, not all. So on the top, you see that we have all the Iotivity features except the security. So that's now in the works, but the target is by the 2.0 timeframe to be fully compatible with the OCF spec. It runs with the various versions of the nodes, including the latest. We have that in Linux, Ostro. You can even run that on Mac. And to use it, start using that, you just issue, you need to install the node. It comes with the npm, which is the package manager. So then you just type in npm install Iotivity node. It downloads everything and builds, and you're ready to go. As we said, we are moving the repository to the iotivity.org, so everything would be under one project. Then a little bit, sequence diagrams, code snippets. This shouldn't be anything new. So on the client, when you do the discovery, as I said, you have a few API calls. The way you start using this module in your JavaScript code is in the node. We have this require mechanism, which is including external modules. So you include that. You tell that, okay, I'm a client, I want to use that in the client mode. Then you register your event handler for the resources found, and then you just issue the find resources. That's it. That's your discovery. And then on the server side, when you want to register things, you use the require. The server mode is the default, so you don't need to specify that. Then you call the register function. You say, well, what is your URL? What type of, these are the OIC resource types and interfaces. And then once the register is successful, you'll get the resource, and then with the resource, you have these updates and events. So if somebody's calling you that, okay, update your resource, you'll get a call. Actually, that's on the next page. But nothing magic there. This is just to highlight that it should be extremely easy to use JavaScript to start building your OCF applications. Okay, so then we'll talk about briefly the cloud integration, what we have done. So we started this work actually maybe at the same time or even before the Iotivity was starting to push the co-app over TCP. And then in the Iotivity, we have the remote access with the XMPP as well. This is not about those. This is kind of an alternative mechanism based on REST APIs. So what we have done is we took the Iotivity nodes and we built an application on top of that, which provides the REST APIs to the cloud. And then on the left-hand side, it's using the CoAP to discover the local resources on the local network. And what you do is that on the right-hand side, you just talk HTTP. So that's the REST API, and then on the left-hand side, it's CoAP. So it's kind of a HTTP to CoAP bridge. So here's the example. So and this was pretty easy to do because the OCF is based on the REST models, and so once you get the the HTTP GET, you map that to the CoAP discovery, and the OIC/REST, that's the discovery, and then if you have anything else, you'll get the retrieve and put equals update. So this is a pretty straightforward operation, and didn't need to invent anything new because the OCF was already specifying the data models and the operations. Once again, pretty similar looking picture. So the Iotivity node, and then on top of that, we're using the Express web server, which is the most used web server in the Node community, and then we built a small application on top of that, which is providing the REST APIs to the cloud. Everything in the API server is JavaScript, and it has the standard OCF 101 features like discovery, retrieve, updates, and observe. And with this, you can have multiple clients from the clouds connecting to the gateway, and this is part of the demo outside as well. So we have the cloud integration there. Then a little bit about the Ostro, as I mentioned. For those who don't know, the Ostro is a new open source project which is providing a Linux-based IoT operating system. And we have integrated all the ingredients that we talked so far there. So we have the Node.JS 4.2 there right now, including the NPM. We have Iotivity Node, which brings the OCF API there. We have few NPM modules pre-integrated, like the Express server, MQTT, CoAP, and then we have the REST API server there as well. So out of the box, you can issue these REST calls to the Ostro box, and you'll get the OCF discovery and functionality without writing a single line of code. We're also working on the Soletta JavaScript bindings, and those will be available in the Ostro as well. This is a fairly new API and activity. So the Soletta project, for those who don't know, is an open source IoT framework. Like Iotivity, it did not have JavaScript APIs. So that's why we jumped in and started to do the JavaScript APIs, and we are using Node.js there for Linux, and but for developer this should be transparent. It has the same API. What's under the hood should not concern the developer. So it has the OCF JavaScript APIs. We also, the Soletta itself has a huge amount of other APIs as well. like the hardware I/O, accessing the GPIOs and I2Cs and etc. It has some software updates and platform APIs, and the list is long. But these four are the ones that we are focusing on right now. Similarly, not similarly, but there was a question about the Zephyr in the earlier session. So Zephyr is a again new real-time OS, small one, open source project announced about a month ago, and the aim here is to offer developer the same JavaScript environment, the same APIs where it makes sense to the developer on these really tiny devices. The one in the picture is, for example, the Arduino 101, which contains, I think, 80K RAM. So we are in the works of building a JavaScript engine there, which would run with the same APIs. How we do it, it's still a bit, we have been investigating a couple of options. One is the JavaScript runtime from Samsung. Another one is duct tape, which is a more established JavaScript engine. These are all kind of geared towards these type of devices where the target is the size, not the performance. In V8, it's quite the opposite. It's all about the performance, and that's why it's big. And later on, there's a talk about the IoT.js, which is an API layer on top of the JavaScript, once again from Samsung. And the libtuv is another kind of an event loop geared towards these small-scale devices. So we really kind of think we can do it and offer a JavaScript environment for these tiny sensor type of devices. And you have the set of APIs there, so which isn't much. I mean, on the OCF JavaScript APIs, we probably only implement the server side. I don't see a big use case for the discovery and client side API there. Okay, more technologies in this area is the Cordova. So for those who don't know what Cordova is, it's a API bridge from JavaScript to native for mobile applications. Mobile meaning iOS, Android, BlackBerry, whatever you have there, Tizen. And with that, you can write a Cordova plugin which exposes a JavaScript API for the developer. So the developer can do a mobile application using web technologies, package that, submit that to the Play Store or Apple Store, and it's there. Once you download it, you cannot tell whether it's a native application written in Objective-C or a web application. And so this Cordova technology, it's been around for a few years now, well actually more, half a decade I would say. It's really popular for the web app developers, and so what we have done is that we once again took the IoTivity codes. This time around, since this is a first implementation is for Android, we took the Java API and all the GNI bindings and all that. And we created an OCF plugin. So now the web app on Android has the same API. So you can write a HTML5 application, you can design your UI with the PC and all that, and then put that on your web app and use the Cordova OCF plugin, and there you have another OCF application. Before that, if you want to use the Android for OCF, you needed to use the Java. And there's nothing wrong with that, but if you do this with web technologies and JavaScript, you can pretty much run the same code on Zephyr, Ostro, Linux, whatever. You can share your code, and the skill set is the same. This should be available within this week in the open source. And how you start using that, again, with the NPM, if you want to use the crosswalk, or you want to use the Android standard web view, you just issue one command, it'll download everything for you, and then you install the Cordova OCF plugin, and you're good to go. We built a small demo on the Androids, and with this one you can just discover everything, every OCF device out there, and once you have the resources discovered, you can click in and start modifying the properties that you discovered. And okay, so those are the technologies. I mentioned this smart home demo for several times. So this is the add section for that one. So it's built with the Iotivity node, with the REST APIs for the cloud integration. The cloud app is shown here. So all these energy consumption and you have quite a few other properties are fetched with from the gateway running the REST API server, and then you have multiple of these sensors there. I think we have like 9 or 10. So they are visible here, so you visualize the data in the cloud. We also have a 3D model of the smart home. So you run this one on your Android tablet or a browser. It's a WebGL, so you can rotate the house and click on the fan, and the fan will start rotating. And as I said, this is available on the exhibit hall. It's all the way down the back, close to the window. So please visit that area and check it out. Everything in the demo, in the application code, is written in JavaScript. So that's kind of the proof that you can actually do these end-to-end type of applications with this. So briefly the next steps, what we are planning on doing. Node-RED is yet another application on top of Node. It's kind of you can visualize, it's kind of a flow type of programming. You have a lot of modules there, like HTTP server and CoAP, and you can just draw your application and then connect them and tell that, okay, now this event means this one. And so what we are planning on doing is adding an OCF Node-RED component. So the people who are using the Node-RED can just drop in an OCF component there, either client or server, and draw the application. And then I already mentioned the Zephyr and Soletta, which has been studied. Security is a big thing that deserves a talk of its own. So as a summary, we've covered a lot of different technologies, OSCs, APIs, but the core piece of everything is the OCF JavaScript API, which is standard across all the OSCs. You can use multiple operating systems, and the IoTivity is the core technology behind the API, but it's not the only one. So with that, I hope you kind of get the vision that was presented on the first page, that you can actually use JavaScript for everything in the IoT. All right, with that, I'll turn that over to questions. I think we have a few minutes. Any questions, comments? Mike?
To be clear, did you have to do anything to Iotivity itself, or everything you did was layered on top of the same side?
Yeah, so the question was that did we needed to do anything on the Iotivity project? Well, yes and no. We filed bugs. We filed quite a few bugs, submitted patches and things like that. But that was pretty normal. I mean, we used the Iotivity the way it was kind of not expected to be used in some cases. But yeah, the project pretty quickly understood that, okay, this might be a good thing. So let's do something about it. And yeah. Okay. Okay, so the question is that what type of a development environment you use. That's actually a good question. In the, well, like any other development community, in the web development community, people tend to use their own, everything. They have their, Emacs and what have you. Web IDEs that they just love and they cannot tolerate anything else, and that's fine. This is not bind to anything. What you use is a editor, and then the npm and the Node environment. That's kind of on the Node side, and you can do a lot of this one on your host machine, on your Linux PC. I use this one on the Mac, and it works good. And once you're kind of happy with the app, you can transfer that to the whatever is the target device and run it there. So the development environment, it's kind of whatever you like, I would say. Okay? Oh, yep. Oh, okay. So the question was that have we measured the response time in this one? Not exactly, but I can tell you a story about the demo that was that the first version was done with the native code, with a different team, with the cute UI and everything with the C and C++, and then the folks who have been running the demo were kind of excited when they heard about our JavaScript stuff, because that's actually on a level that they can type in some code, quickly modify some parameters if things don't work the way they expected. And then once we were ready and showed the demo to them compared to the old one, they said that, wow, this is fast. Because it's not about the execution, how many instructions you can execute in a cycle, or it's more about the end-to-end. So there's so many other kind of delay points in the Iotivity. The sensors are slow, the buses are slow, you have the network delays. So at the end of the day, the speed of the JavaScript engine may not be the biggest bottleneck. But no, we haven't measured anything yet. Okay, 3 at the same time. That's good. I have 5 minutes. Oh, that's a good question. No. Oh, yes. The question was, how is this work that we have done here should be related to or is aligned with the Web of Things, which is a interest group inside the W3C. And actually the question or the alignment should happen at the OCF and W3C level, not in our project. I mean, we do whatever the OCF tells us to do, and I know there is talks from both sides trying to come to some conclusion which way is to which way we go. But the OCF folks being busy with the all-scene integration and then W3C coming in at the same time, maybe a little bit too much. But at the end of the day, that's what I see should be done. And I haven't seen any disagreements from any parties yet, but it's just something that is not done yet. Okay? It was.
On your demo project, were you able to achieve any code reviews or code showing using different slides?
Yes, in terms of all the sensor codes, that's pretty similar, but you can actually do that with the C codes. You just so that's really not a good example. They really, doesn't come up top of my head now because the components are, you have dedicated server and client, and then the web UI is done with the WebGL. So with this demo, I would say that the code reuse case doesn't shine right now. The skill set thingy is visible. And the easy of use. I haven't talked with Ulf, who is running the demo, but I'm sure he tuned some of the sensors yesterday when he was setting up the demo, and he could do that. You just launch VI on the whatever gateway and change one line, and you restart the node service, and boom, you're done. No compiling or anything. Okay, was there any other questions, comments? All right, if not, thanks for coming.